This question asks us to find the formula of the following function if it is in the form of that. Okay, so some of the important features of this graph, we can see that there's an asymptote, and that looks like an asymptote at y equals to 5. Another important feature is that point there, which is 0 and 5.5. And I'm not sure if it will need another point, but this point looks like it's going to also be important. So that looks like it's at half for x and at 5.6, 5.7, 5.7 for y. Okay, so in order to solve for this, we need to, first of all, we understand that an exponential or power function has a horizontal asymptote. That horizontal asymptote is, we already know what the value of it is, so it's 5, so we go plus 5. Next thing we have to do is probably use sub in 0 and 5.5 into the equation. So where we had x, we put 0 and the y value becomes 5.5. So 5.5 equals to 2 power 0 plus b plus 5. This is equation number 1. And then we need to sub in the next point, which is, I guess, 0.5 and 5.7. So 5.7 equals to, let's have a look. So it's going to be 2ax. The x in this case is half. So it's a to the power, a times half plus b plus 5. Okay. So now what we need to do, if we have a look at equation number 1, we can transpose equation number 1. And the reason why we want to do that is because it might be helpful for us to know what 2 to the power of b is. So 2 to the power of b, if I just move the 5 over to that side, it becomes 0.5. And then we could potentially leave it like that, because what we know is that in equation number 2, which we have here, it's possible to write 5.7 equals to 2 to the power of 0.5a. And because these two values, because these indices are adding, they're actually timesing on a base level. Okay, so the powers are adding. That means you can actually split apart the bases and write something like this. Now, the benefit of splitting up the bases is that now what you can do is write 0.5a. We know the value of that. The value of that, it happens to be half. So we'll just replace it with half plus 5. We'll move the 5 over to the other side. That's 0.7 equals 2 to the power of 0.5a times by half. And then we divide it by half. Okay, so what we end up with, these cancel. So 2 to the power of 0.5a is equal to 7 over 5. And now what we can do is we can take a log of both sides. So it's possible to just introduce a logarithm. So take, if you want, a natural log of both sides, like so. And what that does to the power is it actually brings it out the front of the log. That's one of the log properties. And so if I just write it down below here, 0.5a log of 2 so it's something like this, and then we divide. To find a, we just have to go, okay, log of 7 over 5 all divided by 0.5 log of 2. And depending on the type of question, you may need to actually provide the decimal value for such a function. So I'll just have a go at calculating that for you. So we know that the numerator, generally they'll want correct to a few decimal places, so maybe 2 decimal places. So let's say we've got 0.336472, which is that part, and then we've got on the denominator we have 0.346573. So if we divide those two numbers by one another, of course, you can also just solve this on your calculator, on your CAS. I'm just showing you how to do it the long way. So you get 0.97. So that's correct to 2 decimal places. That's an approximation. So what we then do is we need to find the value of B. So we need to find the relevant information where we had B. You can see that it was right there. And to find that B value, you can just use logarithms again. So 2b is equal to 0.5, like so. And what can happen is that you can just take a natural log of each side. So log of this, and then log of that. So b log of 2 and then you have 0.5 log divided by 2 log. So get -1. Okay, so the answer is, of the actual equation, we would know that y is equal to 2 to the power of 0.97 x minus 1 plus c. So that's the equation of our exponential there.